Well, hi, good morning. Thanks so much for joining me in my shop. Hey, I ended yesterday's video with this radio not working properly anymore. So my goal today is to simply figure out what the heck has happened and correct it, because I did do 4 part replacements and then test the radio. And now, before I started the video here today, I've carefully gone through these component replacements, looking at the schematic, and everything adds up fine. It all matches the schematic. I think one of the things that was causing me to stumble when I was analyzing this is the terminal here on the volume control. This is the bottom terminal, if you like. On the schematic, it's the bottom terminal. This terminal should be grounded. Somehow I didn't spot it, but there's a wire that runs all the way over to here to a grounded terminal. So this is solidly grounded. This is a ground point. It can be used by any components. Once you've established a ground point, you can hook anything up there that needs a ground, and that's what these guys are doing. They're finding their ground connection on the terminal here, and I was kind of twisting that all around in my head. Consequently, all this is wired properly, but as I'm going to show you in a minute, this capacitor may be way off size, this blue one here. So we're going to double check all that and maybe even look more closely at the schematic. And every time I look at it, I get a little better grip on it. And that's the way it works. That's how this goes. Doing this stuff is like so many things. It's iterative. You got to go over it and over it and over it, especially if you're an idiot. If you're an idiot, it's really iterative. Okay, now what about this? I showed this to you yesterday. This is the power supply from my son's TV, which stopped working the other day. And here's what I found on it. Okay, so this diode is shorted. Put an ohmmeter on this, it's shorted. It's come out of the board here. Its brother right here is fine. But that's not all I found. I also found that this voltage regulator here has got a short on it. And the Zener diode down here appears to be shorted also. So I believe what happened here, you can see this is a separate, very separate part from up here. There's a clear delineation there. Some kind of isolation transformer bridging it. A couple of capacitors. Anyway, so I believe the story here is diode failed. Excess current overload the regulator in the Zener 2, or maybe overload the regulator. Regulator shorts, Zener pops. At that point, it's just too much, and the fuse books it also. So these wires, by the way, are my temporary fuse holders, so I could temporarily put a fuse in here and power this board up on my bench. So so I got to get 3 new components. Unfortunately, I'm having a hard time doing that. This is a Schottky diode. So far I'm having a hard time doing that, but hopefully I just find these 3 little parts, pop them all back in, and TV set working again. Okay, let me put this on. So I think I'm gonna need to start by looking at the schematic here and just verifying. I got to the point where I found this capacitor and thought it was wrong, and I thought, okay, now's the time to turn on the video because things are getting confusing, and I love so much to confuse whoever is watching this with me. I like to share. I like to share the confusion. So let's go pop over to the schematic here. Okay, here's the schematic diagram. The part we're interested in is right in here. Right in this area. Let's zoom in on it. Okay, and hold still. There we are. Perfect. So here's the volume control right here. And here's the end that is grounded. And you see this capacitor here, which goes to ground, or the chassis. This is the one that's connected back to this terminal. It just confused me a little bit. But I'm not confused now. So that capacitor is correct, 0.015. The one I'm finding that's a little unusual, let me just, there, if you think about the signal coming out of the radio, it's coming out right in this area here. It's coming through the detector and coming out right here. You want the AC part of the signal, the audio part, to head off into the amplifier. You want the DC part to head this way into the radio to provide bias on all these grids. And this great big resistor separating these two parts away, 22 meg resistor here, and a fair size capacitor, 0.05, for this kind of purpose. This is kind of smoothing out everything and also causing the damped effect of the AVC voltage shift or change as the signal strength goes up and down. Okay, so that's what's going on that way. The audio is coming this way and down this wire through here. Oh, there's a connection. Some of it is going back up here, around through this capacitor. This is the one I'm questioning, and heading into the back door of the volume control, as I like to call these fourth tabs back doors. So think about that now. The sound of the radio is being fed into the middle of the volume control through a capacitor. Okay, and if we carry on, whoa, I went the wrong way. Okay, so we carry on this middle wire here all the way. Now it's the lower one here. It comes down to this switch called frequency modulation. And on my radio, I think this could say phono input here, is what it could say. So the switch is shown in this position. You could move it down, and then that would connect this wire here to this wire. This wire goes back, and look, FM input jack, or on my radio, this is the jack on the back that says phono. Pretty sure. So it's not in phono mode on this diagram. So that means the signal travels back on this upper wire. Just a second here. Okay, on the upper wire through here, comes to a smallish capacitor, 0.005, and arrives at the top of the volume control, where a portion of it is then peeled off and sent off to the amplifier. Now if you look at this diagram, you can just about imagine that at one time these wires didn't exist, and this was drawn straight down into the volume control. And sometime later, as they improved this radio, maybe included a phono input, they redrew the schematic. I'm just making this up, of course. They redrew the schematic by breaking this line and then feeding this all the way over there. So it's a simple matter of switching the signal that arrives at the top of the volume control from either phono, FM, or out of the radio itself, out of the detector. Okay, I think I got that really quite straight now. So 0.005 coming back. And this one here, let's focus on this guy now, because everything else is correct here. So there's basically a capacitor connected to every terminal on that volume control. This one here. So that looks to me like it says 100 picofarad. C50. That's R24. What's this number 3 here? Okay, so I don't know what the 3 is. The mysterious number floating around here, R10, 1 meg. R10 must be the volume control itself. Okay, so in microfarads, 100 picofarad would be 0.0001, 3 zeros and a 1. So let's go look at this capacitor. I can stare at it all day. It's not going to do anything here on here. Let's go. Okay, so the capacitor in question is the one coming off the where? misread this. Coming off. No, yeah. It's the one coming off the back tab going there. So it's this one back here. No, it's not. No. Wait a minute, I'm losing it here. How did that happen? How did I get so confused? I'm really good at that. It's definitely a capacitor coming from the back. See, there's a capacitor coming off this back tab. Here's the back tab on the far side of this resistor. There's nothing else coming off there. Nothing at all. So this shows what's happening here. What is happening? Okay, let me set something up on the screen or make this a little better. Okay, this might make it a little easier to track this stuff down. Now, you're looking at the schematic, and we're looking right at this point here. So this is the back tab on the volume control. Should have two things coming off it: a resistor, 27,000 resistor, and another wire or a capacitor. Like the wire would lead to the capacitor. This capacitor may be located elsewhere. It could, who knows where it could be. Doesn't necessarily mean it's within view, right next to the control. But there should be two things coming off this back tab. I can't see how I'm misinterpreting that. So now when we look at it, there's no power in this radio, by the way. So here's the what I call the back tab. There's nothing but one resistor coming off it. A resistor that appears to be splitting open here. And there's never been another wire connected to that. So, you know, jeez. As far as I know, the radio is wired exactly as it was the last time it worked. But it doesn't appear to work anymore. Not properly. I can't see anything here that I need to change, even though it's not matching the schematic exactly. Now, what would be different? What would change? Let's see. That capacitor, if I look at the schematic again, so this capacitor, well, does this exist at all? What, or is it just completely missing from here? 22 megohms, so that would be red, green, or something like that. I think. So I'm looking back in the radio here. Don't see anything like that. Okay, that was a lost cause. It's going to get a little quiet here because I'm going to be using as much of my brain as I can. So, yeah, that 22 meg resistor could be anywhere in the radio far away from the point we're looking at. See, the thing is, let's not say that. So coming off, let's just double check. Coming off the slider, it's a capacitor going to this pin with a resistor to ground. I can't remember what the size is. So off the, so how's that compare? So if we look at off the slider, the capacitor here, I got my finger on, is this one up here. 0.04. It's kind of an odd size. 0.04, and the size is hidden here. Oh, I hate rotating these things like this. 0.005. So it's a 0.005, even though the schematic is saying, hey, 0.004. I can't imagine that's going to make any difference. That's correct. So that's in the correct place. What about this one? This is coming off the other end of the of the it's coming off the top. So that would be this guy, 0.005 again. Cannot read the size, but not physically identical. And this is what potentially heads off. Look at the wire comes around. Look at that! It disappears into this hole through the cabinet and heading up to the top. So it's heading up to the buttons almost certainly. So that's good. That's fine. It's all making sense. Now let's try from the center pin of the base switch. There is a capacitor that comes along to this post beyond the resistor. So we look at this, try that again. We start at the center post, which is way down here. Center post, follow it up. There's my capacitor I put in, and it continues up to the terminal post. Perfect. So that's fine. What's left here? There's really nothing left. So it's as if they just didn't bother with the capacitor from here. Why would they show that on a schematic? And what is it anyway? It's the weirdest thing. It's a feed around. It's feeding the signal from the radio back, a little bit of it anyway, through a small capacitor. I don't know, some kind of a tone thing. I don't know. The actual purpose of this back here, as far as I understand it, this is to try to linearize. Oh, there's a word. The volume control. So all its action isn't contained in 15% of its rotation. We're trying to spread its action out further. That's one thing I understand that this could be doing. And the other one is you can, as you turn the volume way down, kind of inject more bass into it and get this loudness type function happening in a radio. So I don't know what the truth is. I've got to turn this guy on and listen to it and see what's going on. Okay, I think we're about ready to start this guy up. I've got the signal generator back here producing 1000 hertz audio tone. It's fed into the phono input here. This antenna is of no use. Let's get that out of there. Okay, and this will give us a chance to find out if this control up here, the one with the 3 settings on a 2-band radio, yes, a number of you have pointed out the 3rd setting is probably switching in the buttons at the front, and among those buttons is the phono input. So that's probably a preset tuning phono button switch. We'll find that out. So right now though it's on the AM radio. That's where we're starting. Volume down, I'll put it up a little bit. And we'll put this tone thing on the open setting. Okay, and gotta plug it in here. Everybody ready? Is everything okay? Let's get this unnecessary cord out of here. I like a fairly neat bench when I'm starting this stuff up in case I need to panic. In case a panic is required. I like to panic under control. ABC, always be controlled. Okay, here we go. Just tightening up one of the bulbs in the dim bulb, which I had loosened off because I was powering up that TV power supply board earlier, yesterday actually. This is the fuse I took out of that board, by the way. Doesn't look like a fuse to me. I'm used to fuses looking like this. Okay, this guy's warmed up, I'm sure. Where's all the popping, the noise, all the crashing and excitement that happened yesterday? And is that stuff somehow related? I didn't hear any of it today. Okay, turn it up. Nada. Okay, let's I'm gonna turn it up. Oh, this is even worse than yesterday. Okay, let's give it full voltage here. Wow. What? Is the set really on? Tubes are warmed up. Oh, smokes. She's a complete dud. Wow. Okay, I really. It's a race to the. It's a race. I'm losing it. What could have happened? Anybody, somebody. Oh, I heard a little click. Let's disconnect this. Turn down the volume. It's possible this is actually shorting everything out. Just hang there. Did not have the phono button pushed. Okay. Journey downwards. Okay, let's try and engage the phono button. Phono. Okay, so I'll push the phono button here. Now, supposedly this is still in AM radio mode. If I turn it like this, this I'm guessing is phono mode. So there's nothing coming out of this radio at all. Now that's an input to the grid on the. Oh. I hear a little something. Let's try pumping in the audio signal here. Volume down. Volume up. Level up. Level way up. That's doing that ABC thing again. Almost like a reverse ABC. Volume full. Yeah, it's doing the same thing. Okay, so I think we are where we were. That's great. I'm in the same. It's great to start off in the ditch you left off in. It's just faded right out. Well, let's see. We still get almost nothing out of this. It should be humming like a son of a gun when I touch that. So, possibilities. Totally shorted out resistor. It's just not really very likely. That would null. Let's move a little further up. There's an inverter tube. That would be this one. And then there's the two output tubes. Why don't we apply something to the grid of the output tubes? Just want to get it on. Oh my gosh, somewhere in this network of schmozzly stuff here. It's up on the screen. So I could try to shove this. See, right now I'm shoving the signal in way back here. You know, let me shove it in right on this line here. Maybe I'll go on this side. Let me go on this side of that 0.04 turns out to be 0.05 capacitor. Okay, level down. Whoops, not off, just down. Down. Clip out. So we're going right on the grid. Right upon the grid. I really should be doing this with a capacitor. Let me do that. It's just... I don't put a capacitor in there, I may throw the grid bias off or something. This is past the volume control, so this is a wide open amplifier. Okay, we're still getting that weird. Yeah, that's it. Well, it's possible something has failed in the middle of me doing this, like a tube or something like that. It could be a tube contact. Hey, all that clicking and crackly stuff has gone away. Okay, let's try this. The clicky, crackly stuff went away. It could be whatever was causing it has found itself in an open sort of position. So let's do this. First of all, are all these tubes hot? The answer would be, oh, ah! Yeah, don't touch the output tube. Yeah, wow, okay, plenty hot. Haven't even cleaned this guy off yet. So what I'm going to do is I'm going to clean them off. I'm going to pull every tube out, shove it back in, turn the set back on after that, and we'll see what we got. Okay, so I did pull out all the tubes to clean up the chassis and clean up the tubes, get the dust off them and that. Well, I should really tube test them now. So I have the tube tester set up for a 6SQ7. It's a 6SQ7. And I'm going to go through the audio tubes, or the tubes that could affect the audio part of the radio, and see if we can find something funny going on there. So I know, you know what, I don't know if this is the first audio amplifier or the inverter. Not that it really matters at this point. So stick them in. Just go over the settings here while it's warming up. 6SQ7 6.3 JX 1603 with a 2, 1603 with a 2, 1134. We're good. Okay, let's check. Whoops. Let's just do that power line adjust deal here. Okay, now, is there a short in this radio? Again, if there was a short in the tube, if there was, it would be pretty apparent in the radio. Okay. Before, what are we looking for? Tell them what they're going to get. Above 470, as high as 750. The 3000 scale above 450. That's not very far up on the dial, just up around here. There we go. So that's great. Now I'm just checking the triode part of the tube because that's all that this radio is working with. Let's put the other one in. That one certainly tested just fine. We'll test the two output tubes after this too, which I see have been replaced. Typical in a radio like this that the output tubes would have a relatively short life. Okay, B4 once again up around the 500 here. Well, that's still rising a bit. So it's testing good enough anyway. One is slightly stronger than the other. Can't imagine that's going to make much difference. Now we want to find 6V6, 6 TUV, 6V6, there it is. 6, we'll just go ahead and do it. 6.3 JR, JR, 5347, 5347 with a 22, 21 and 85, 21, 85 on the English. Okay, let's put one of these in. Clean them up real nice, eh? Okay, I can see it warming up there. Shorts, just in case something happened on the way over here. Okay, what are we supposed to get? 6v6, we should see, excuse me, minimum 2300, maximum 37. Wow, that's quite a way. So it might even go off scale. I'm on the 3000 scale. Off scale. Nope. 20. What's that lower number again? 23. So you know it's hanging right around the 23 mark here. So you know, not a lot left in this guy, but certainly functional. Certainly functioning. And what, you need these tubes to be 100% when you go to turn the radio at full blast. How often do you do that? I don't do that very often myself. I do it accidentally here in my shop. That's where I turn things up full blast. No problem. Once again, talking, what was the numbers again? 23. Right up around here we go. Oh, right over. So, yeah, these are two different vintages of tubes here. This is a Phillips, and the other one I think I did away with it. Oh, it looks like Phillips also. They're identical. They are identical. So these probably went in at the same time. You know, the radio went in the shop. Maybe the guy who did the capacitors changed these. So these were purchased brand new, and assumably they work exactly the same, and they ran in the radio together in a push-pull arrangement. You'd expect them to wear out together and to always show the same strength, all other things being equal. So that, I don't know what that would indicate. They share a cathode resistor, so they share the bias. Okay, well let's do a few radio tubes. You might as well. I'll just keep the video rolling, Jimmy. 6K. No one's ever called me Jimmy, by the way. 6K, JK. Actually, my parents called me Jimmy. What am I talking about? J4. JR. Concentrate, Joe. This is important. 0, 3, 4, 7, 5. Let's double check that. 0, 3, 4, 7, and the 5. You notice when I'm pointing, I point right at the actual little pointer that are on these controls, because occasionally I get the control turned right around 180 degrees. I know the mistakes I make, and I enjoy them too. Okay, 6K, 7. So, oh, cap. Oh, we need a cap. We need a cap. Cap here. Which cap? Cap equals G. So we need the grid cap. It's just a little awkward here to do this. That's the wrong size. Okay, I gotta find another cap here. Hang on. Okay, I'll have to keep my eyes peeled for a smaller grid cap. I've got a few of them in my parts boxes. It was lots of fun going through those parts drawers and that, but I couldn't find one small enough to hang on to this. So we're just going to use a clip lead. Is this set right? Am I right? 6.3. This is all done correctly, I'm pretty sure. 6K7. Oh, 3, 4, 7. Oh, 3, 4, 7. Just making sure what's in my head somehow approximates reality. A lot of truth in that, you know. What's what we see, what we hear, what we think is all approximation of reality. Generated by our oh so powerful brains. Here we go. Okay, everything's good there. 6K7 should 1450. 915 at the bottom. So on 3000 scale, 9, so above the C and replace. Yeah, good. Okay. The next one is a 6A8 tube. Let's make sure let's not plug it in just so quickly there, Joe. 6A8. Two tests on a 6A8. 6.3 JR, good. 0347 0347 with a 5. Really? 2250. So it's the very same pin arrangement as the 6K7. Is that right? 6A8. At least this half of it. JR 0347. 0347 with a 5. Okay, good. Grid cap. The odd tube has a plate cap, by the way, so fingers away unless you know what you're doing. And the reason I say that is you can touch grids here and fool around with your radio by touching these with your finger. Occasionally that's a plate, and it's going to have a high voltage on it. So what are we looking for here? 6A8, test number 1. 630, just above the P. Oh! Wait a minute. It's jumping around here. That's a little better. Okay, so it's good too. I'm left with now is the 6H6 detector tube and the 80 rectifier. I'm not going to bother with the 80 rectifier, but we'll do this one, the 6H6. So it's FM on it. H6. GH 6H6. Hey, I didn't do both sides of the other tubes. Whoops. Let's go back. Oh, mistake made. Almost made. Let's go back to the 6A8. 6A8. Number 2. Put it back in here. This tube tester, you can change these controls and not worry about damaging your tube or your tube tester. Other tube testers, no. Never put a tube in until everything is set. This guy's safe. JR 5647. 5647 with a 3. 3073. Isn't this exciting? 3073. P4. Oh, what's this say? Oscillator section. Big message in here. Micro modes only, okay, over 240 on 3000 scale. Only over 240, so it looks like we're shooting for 300, and if it falls below 240, then this tube won't oscillate. That's kind of interesting. The grid cap's not important in this particular arrangement. Cap equals G. So that's the grid that's going into the triode. as opposed to this part. Does that make sense? We'll leave it off. Leave it off for now. See what we get. Leave the grid cap off for now. Over 240. Okay, so 240 is way down here. 500, 400, 300, 200. So basically at the tip of the R, the foot of the R. So it's above the 240. We're really trying to get to 300, I believe. So 300 would be, yeah, it's more or less 300. Okay. I think she's good. Now the 6K7, was that also a two-parter and I skipped the second part? JK, no, there's only one. So we did that. Okay, good. So now we're down to this, the 6H6. 6, oops, HIJ, A6H6. Here we go. JR 0507. 0507 with a 0. 0. It's a rectifier. 61. Press P1. This has to be on English for this to work. And it's a good bad deal. No, it's above this. Got to get above the diode's OK mark. It's not going to get there unless I plug it in. Okay, so the light's not flashing. There it goes. Good. Okay. P1 for diode above the diode's OK. No problem there. Next one. JR 0304 0304 0061. All the same. No flash here. JR 03040 03040. That's correct. Hey, we got a no-go. I'm just watching for this needle to pop up ever so slightly should I manage to engage a heater that's not engaged properly. I like that, eh? Appears as if half this tube is missing because we got no flash, no charge buildup. That's how I do that. 6H6, I got a ton of those. Isn't that interesting? I think it's interesting. I gotta go find another one of these and we'll see if we can get one that works on both sides. Okay, I had to dig deep into my tube collection to come up with these. What was that for? What are these little guys? I don't know. Here we are, 6H6, 6H6, 6H6. I think any tube that looks like this is a 6H6, I think. And there's enough of them there. Okay, so this is the one that's dead on this setting. Did I push P4 instead of P1? No. Let's go with this. Oh, it's okay. Really? getting the flash now. Wow! That's more than okay. That's crazy okay. .6H6 for sure. It's a crazy okay on the other side. I think we got one already. 0507. 0507. 570061. Yeah. P1. Here we go. So there's the flash. P1. That's our guy. This is our guy. I'll put him over here. This is the bad guy. We're going to give the bad guy another shot. Another shot at life. Give me just a moment. There's the flash. Tube's warmed up. P1. So on the one side. Not too bad on the one side. The other side. Watch it test good this time. 0304. 0304. Everything else the same. No flash. No flash. She's a dud. Done. These ones we're not going to find out about until someday down the road when I need one of them. Very good. This guy's going to go into the garbage right away. Now, how can this possibly help this radio out? Because the detector's not really part of the audio section. But you know, I don't know. Let's plug it in and see what happens. I gotta plug all these tubes in. I gotta plug in all the tubes. Okay, let me plug in all the tubes. Okay, ready to start this guy up. Now, it's still set for phono, I think. No, actually, you know what? It's set for AM radio up here. The phono switch is pushed here. Audio signals being driven right into the grid of one of those. Either the preamp or the inverter. I believe it's the preamps coming off the volume control. It's got to be the preamp. 6Q7. So the detector problem could not have affected this, as far as I know. What do I know? Okay, volume down. Tone anywhere you like it. Switch starting open there. This is off. And we'll tone down the input level just in case something has happened and she comes on full blast. One thing I did do is I pulled all the tubes out, stuck them back in. If there was a 2-pin contact problem, that's probably been resolved now. So for all I know, this radio is going to come to life full tilt. No volume control here, only here. I think I'm going to turn this even lower. It's really minimal. So if we get a screamer going, I'll just shut the power off. I feel like just to unclip it. I think we're ready. There we go. Dim lights are dim over there. Volume's right down. Full power. I'm not sure what I'm going to hear. So you know, I'm going to detach this here. So it's set to AM radio. Wow, it's just. It's even worse. Okay, hold your ears. Well, I'm going to guess somehow I've introduced a short circuit here somewhere. Something like that has happened. And really wrecked this radio. Let's go back to, let's pretend that's phono. There it is. Still doing that thing. Really, it's just screaming out bias problem of some sort. Let's see if we can feed the signal right onto the grid of the output tubes. I think I was about to do that when I decided to pull them out and clean them up and stuff like that. So to get onto that spot would be far. Okay. So I remember now the two resistors off the grid. I know where this is. So we should be able to inject the signal. Okay, so I'm going to shut the power off here. See, I should finish the sentence once in a while too. I'm going to inject the signal right into this spot here. And I'm pretty sure I've connected to here. This should pump a signal into both grids. Ooh, you know what? They won't be, yeah, they won't be like this. They'll be like this. If you run these two tubes in common mode, I don't think there's going to be an output. So, how do you do this then? How do you have to get right on the grid of one, not in between on these resistors. Get it right on the grid of one. So off the plate of each of these tubes is a capacitor, and on the other side of the capacitor is the grid. So what did I say? Off the plate of each of those tubes. Okay, 6V6. 6V6. 6V6 plate is pin 3. Pin 3 on the 6V6 plate. Now 6SQ7. Let's try it again. 6SQ7. Plate is on pin number 6, so we should look for a capacitor off of pin number 6. So we come here, this radio is off. Come here, we go 1, 2, 3, 4, 5, 6. There's the capacitor, there's the other side. That's the grid of one of the output tubes. And now we should be able to do the same thing with the other one. 1, 2, 3, 4, 5, 6. That blue capacitor is it. That's the grid down under there. Start with that one. Again, this could be enormously loud. Jeepers creepers. Yeah, life, what's going on? This is where I now make a firm clip to the wrong spot. Let's see. Okay, that's not going to go anywhere. Okay. We're on the grid of 1, 2. All I'm hoping to do is just make some sound come out of this radio loudly. Okay, we'll just do it on a lower supply voltage. We'll cut this way back before we blow our ears off. I think this should work. Crazy what I'm doing here, but who cares? Here we go. Barely hear it. There it is though. Okay, volume should do nothing. Now I'm going to switch from this tube to the other tube. We'll see if it's the same level of volume. That sounds like a valid test to me. I don't know. Okay, so pin 2 was coming from the other side of this yellow capacitor. So the set is off. Other side of the yellow capacitor. Follow the yellow capacitor. Just want to make sure I get it clipped on there and the clip doesn't wander into a short. Looks good. Power on. Should get the same level of volume. That's what I believe. There it is. Sounds the same to me. Doesn't sound distorted. Sounds very, very good. So I think we've proven the output stage works. Now, I just want to go back and pump the signal into here, which is the same as pumping it on the far side of the slider capacitor. These slider capacitors, that's there. And we should get a lot louder sound out of it. So I'm going to cut this back. Take this off, put the radio on. Scare me, man. There we go. We'll now move it over here. Well, this radio should be screaming out at us. And you know what? It's actually... Let's make sure we're not killing it here with this. Nothing. So I'm pretty sure we're on the grid of this tube. Now what if we get down onto the grid of the other tube? How do we do that? We simply find out what pin it is and go there. So if that's the grid, that is pin 1, 2. So the other inverter tube 1, 2. Cut the signal back before we blow our ears off. 1, 2, buckle my shoe. Oh, don't do that. Don't do that. So how this is kind of carried. So we're feeding a signal into this grid. We're hearing it okay. We feed a signal into this grid. We don't hear it. Let's go back and double do this. Pin 2. Is it really? Let's just make absolutely sure. 6SQ7. I want to introduce every opportunity to make a mistake here. 6SQ7. Pin 2 is the grid. Pin 2 is definitely this one. Now, so let me go there. I don't hear nothing. So the output of this tube is the input of one of the two other tubes. Why don't we listen to the output here of this tube? The output I believe, yeah, it's right on this. So I'm basically feeding a signal into the grid here, and I want to listen to it on the day. Hey, getting a little long in the day here. Long in the day. Beautiful, beautiful day, and here I am in my shop again. Okay. What are we listening to now? We're going to be listening to audio. Make sure my audio guy here is right. on audio. So if we touch here, oh, we should hear that signal, 1,000 hertz. What's up with that? That's mighty hard to explain. That's really not possible to explain. I hear it. Where am I hearing it from? Okay, it's coming. I can hear it now. It's kind of behaving like there's a short circuit on this pin. Like all the signals just being yanked out of it. You know, if that's the case and I remove this, then the signal tracer will come to life. Well, it's starting to come to life like that. You can do it this way. Exactly the same. They really got very little signal coming out of that. That's really what's going on here. So that's the signal tracer you're hearing. And that's the radio. Let's just rotate these controls up here a little bit. What happened? Well, I think I've located the trouble is in this stage here. What could have happened? A short in there that I haven't spotted yet. Okay. Well, I think I'm going to stop at this point. I'm really focused in on this 1-2 area. We'll go through it more carefully tomorrow and try to figure out how I boot this up. How did I boot this up? Okay, so the success today was finding half of a 6H6 dead and knowing now that the rest of the tubes are functioning well or okay in this radio. And I've localized the audio problem appears to be in this stage, and I'm quite suspicious it's because of something I did, and I just haven't discovered what it is I did yet. But time is on my side. Okay, thanks so much for watching. See you next time.